Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. In this episode, we're back on the road with energy and transport journalist David James, who's looking into e-turbo technology for hydrogen fuel cell vehicles. Just a reminder that if you'd like to get these podcasts as they come out, be sure to subscribe via your favourite podcast app. Right, David, over to you.
An APC collaborative research and development project led by Cummins has developed an e-turbo that will make hydrogen fuel cells more efficient. Now, I didn't think fuel cells had turbos, so I decided to go and meet Laith Al-kazaz, the Director of Advanced Engineering at Cummins, to find out more. Not only did he explain how the e-turbo works, he also said the technology developed on this project will also save 200 million tonnes of carbon emissions from conventional internal combustion engines over the next 10 years. This project, called Trident, is a collaborative R&D project delivered by Cummins, the University of Bath's Institute for Advanced Automotive Propulsion Systems, and SMEs Hodson and Aristech. So just tell me about Cummins in the UK. What do you guys do?
So Cummins in the UK, we're part of the larger Cummins unit based in the US. We're one of the kind of satellites, so in a different region in the UK. We've got various different companies, different business units. So this one in Huddersfield is the Cummins Turbos Technologies predominantly. But we do host people from the other business units. So we have other business units such as the engine business unit, so the manufacturing engines, after treatment, and then also fuel systems. And now we're also looking at EVs or ZEVs as well. So it's a very wide product portfolio, very diverse business. And I say it's a growing and expanding site.
We're obviously moving towards an energy transition, low carbon technology. Cummins famous for internal combustion engines. What's the transition looking like? How's it positioning itself as an organisation?
Certainly an exciting time. I think both ourselves and our customers are trying their best at the moment, trying to understand when that change will be and how quick it will be as we transition over from the internal combustion engine to ZEV technologies. We're still pushing at the forefront in terms of diesel technology to make sure that the existing technologies and product we have out in the market at the moment are as environmentally friendly as possible and as efficient as possible. But at the same time, we're accelerating as quickly as we can, and this is part of the APC group, and the work we're doing now is to move as quickly as possible in the ZEV space. So looking at fuel cell technologies and hydrogen ICE as well. And from a Cummins point of view, we're looking not only at the powertrain itself, but also producing the hydrogen. So we're really diversifying our portfolio. So we've bought companies that work in battery technology, as mentioned, the generation of the hydrogen as well, and also more and more looking at the vehicle as a whole. So we've worked with Meritor now in terms of the electric axles as well. So it's a really wide product portfolio. So as and when that change comes, we're ready, and we've got each of those different technologies covered as much as possible.
Tell me about Project Trident.
So Trident's been a really interesting one. It's been a really wide ranging project, working with lots of different partners. We've covered everything from the ICE space, so diesel, natural gas, hydrogen ICE, but also developing hopefully a market-leading technology advanced e-machine, so an e-turbo for use on fuel cell applications. So we've developed new analytical techniques to be able to use on the existing architectures, such as the ICE space, but some of those will transition through and be equally applicable to the fuel cell e-turbo. We've developed new analytical rules and tools with our partners at IAPS, University of Bath. That's helped us to understand more the application, the requirements of the application, and choosing the right architectures as we move forwards. We've worked with our friends at Hodson and Holtex, who've now moved forward in terms of the technology, in terms of electrochemical machining, so improving the surface finish of some of our products, and then obviously Aristech on the e-machine.
The main output is an e-turbo. What is an e-turbo?
So if you think of a conventional internal combustion engine, we take the exhaust gas, which is effectively wasted energy. We use that to drive a turbine, which in turn pulls in fresh air through a compressor, feeds it into the engine, so we've got more air, more energy, and we're able to get more power output from a certain size of engine. So we're now looking at doing the same thing now, but for a ZEV or a fuel cell vehicle. So it is a novel and expanding technology, because when we look at the first phase of fuel cell electric vehicles, they were using very low pressure air supplies and effectively an electric blower or compressor. We're now looking at taking that to the next iteration, next level of technology, and effectively applying turbocharger technology but on a fuel cell. So we're taking some of the wasted energy from the fuel cell output, using that to drive a compressor as you would do in a conventional ICE application. But also we have to assist the turbocharger using the electric motor, which is where it differs from an internal combustion engine. And that's really what the key technology and driver has been on the Trident development with Aerostech, is that development of the motor and obviously the aerodynamics and so on, and the electronics to meet the specific requirements of a fuel cell vehicle.
So it really is fuel cell vehicle that we're looking at. The e-turbo won't go on internal combustion engines, or it's not designed to do that.
This particular turbo isn't. There are different flavours of e-turbo, so it is possible to kind of have more of a hybrid between the e-turbo we've developed with Aerostech and a more conventional turbocharger. One of the key technologies we've been working with Aerostech to develop is the air bearing technology. So a conventional turbocharger effectively has a set of bearings and they're oil fed. And that's been how it has been for 70 plus years. In the case of a fuel cell electric vehicle, we do not want to contaminate the fuel cell, so we're not allowed to have oil carryover into the airstream. So that means we can't use this oil-fed bearing system. So the bearing system on the e-turbo is an air bearing system, so it's effectively floating on a cushion of air. So that's a really fundamental difference between an existing turbocharger and an internal combustion engine and what we need for a fuel cell.
So what's the advantage of having a turbo on a fuel cell?
So I'd say it's similar to an ICE application really. So you have the wasted energy that's coming out of the exhaust pipe or out of the fuel cell. And really normally that would just be expelled to the atmosphere and not used. So by putting a turbine stage on an electric compressor and becoming an e-turbo, we can take that energy and approximately 20 to 30% of the energy that's needed to drive the compressor side, we can take from the wasted energy from the fuel cell. So in short, it gives us a much, much more efficient and high performance fuel cell electric vehicle, because that system as a whole is far more effective and efficient than it would have been otherwise.
Have you got any metrics? I'm assuming you've got to the stage where you've at least trialled it, but have you tested it? How much more efficient is a fuel cell with your e-turbo on it?
So the quick answer is we've run analysis, and I'm not going to give numbers because we don't want to be quoted on them. The reality is we have units now that have been shipped globally, and we're doing independent testing and evaluation in Europe. And we've also shipped some units to China, and they're going to go under evaluation now. So they'll be running them in test laboratory environment to try and quantify the benefits before they potentially go on vehicle. So again, as in conventional turbocharger, it will verify application to application, engine to engine.
You're a business, and you're doing this because there's a commercial pull-through. What's it looking like? What's the market opportunity for this kind of technology?
The market opportunity is definitely there. I mean, this is a technology that will be required and is required. The big question within the global industry at the moment is the market adoption rate. We can develop the technology. We've got very smart engineers both within this group and externally. We can develop the technology relatively quickly. The big question really is the infrastructure going to be there to support it? So when you look at not only the fuel cell electric vehicle, but also hydrogen ICE, both of those are very reliant on having the hydrogen infrastructure in place. A little bit akin to the ZEVs, you have to have the charging points in place to be able to support the technology. So from our point of view, we and our customers very much in the evaluation stage at the moment, trying to understand how robust are these products, exactly what are the market requirements and specifications of the machine, and then that will help to dictate the adoption rate effectively. So over the next 5 to 10 years, we anticipate it being relatively low volume, whilst people evaluate, let's say, the technology and the capability of the technology, start to develop total cost of ownership models. So that's obviously key to them as well. And also understanding where other technologies that might compete with it, such as the hydrogen ICE might go. Because we see a really high adoption rate of the hydrogen ICE, then we may find that the fuel cell adoption rate is pushed out a few years. And the initial market discussions we're having now with our customers, they feel it's probably moved out a year or two from when we started the project. I guess one of the challenges we've had throughout the project has been the change in requirements of the customer, because they are learning more and more all the time. They are building and developing their analytical tools. They are better understanding what their requirements are. So where we started at the beginning of the project wasn't where we finished the project. And again, that's why when we talk about productionization and volumes, everybody's a little bit reluctant, because it could start in the low tens and ramp up very, very quickly, or we may find it's a much slower adoption rate.
Project Trident was supported by the Advanced Propulsion Centre. Just tell us about the support you got.
So APC have been really key in terms of bringing us together as a team, as a collaboration space, because otherwise the danger was we would have worked in isolation. They helped us identify the partners who we could work with, recommend them. Our application was made over Zoom in the days of COVID, so that was a real challenge to all of us. I think APC helped us understand what the structure and the format needed to be in terms of understanding scope, working with the partners, making sure the deliverables were clear to everybody. They've also, APC have been really key in terms of making sure we understood the milestones and we were on track and the spend profiles were as they should be. And I guess in terms of output from the project, I mean, the real key for us, obviously there's the financial side of things in terms of the funding, but really in terms of APC, what we've been able to deliver is we've been able to bring product to market much more quickly in terms of the existing ICE space. So we've probably brought things to market a full life cycle earlier than they would have otherwise been, so maybe 4 to 5 years earlier than we otherwise would have been able to. And the fuel cell e-turbo, clearly, because of the discussions we've been having about volumes and the unknown adoption rate, there was a natural hesitation within the industry to invest significantly in that space. So with APC, with the funding and the structure of the program, we were able to really commit to developing this technology, and we got to the space where we are now, where we were able to evaluate real units in the field. So that's it's been really key. That's what APC have brought to us.
What do you think it would look like without APC support? I
think without APC, I mean, there's a real question about when we would have looked at developing and investing in the e-turbo for the fuel cell. And then in terms of the internal combustion engine technologies we've developed, they would have been pushed out at least another 4 or 5 years. So when we made our application, we showed that without the APC funding and finance and guidance, we would potentially have been releasing some of these technologies to the market in 2030. Thanks to APC, we've now got those demonstrators on the road now in field tests, and they'll be hitting the road in large numbers in terms of start of production 2026. So we've been able to introduce technologies much earlier, which is great from a company point of view in terms of winning business, retaining business, but from an environmental point of view, that means we've been able to release a much more efficient product into the market with all the environmental gains and benefits that has with it.
Obviously, there's taxpayers' money involved. This is government money coming through the Advanced Propulsion Centre. What's the return on investment for the UK?
Well, in terms of the UK, I mean, one of the things I maybe should have mentioned earlier when we talk about the benefits from the APC is when we look at some of the partners we've worked with, I mean, they're the people that have really seen the benefit. From a Cummins point of view, you could argue the size of the organisation is very similar to when we started the product. What this has done is it's basically safeguarded jobs within Cummins, but from the outside we look very similar to when we started. I think when you look at the likes of Aerostech as a business, our collaboration partner on the e-turbo, they've effectively doubled in size over the 3 years we've been working with them. And that's mainly due to the work through APC, the additional funding, the confidence in the technology. They're able to go out and talk to customers. And all of that is UK based, right? So we're all UK based companies in terms of what we're doing. If I look at Holtex, which is now Holson, again, they're a relatively small company. They've now split off into 2 companies. That's a real success story. They've held the IP rights, they've got licensing rights to the technology. So although they're a relatively small company, and you look at it at first and think, well, they can't possibly supply a global company like Cummins, but they have the licensing and they sell the equipment to be able to produce the technology on a global scale. So from a return on investment side of things for APC, we've safeguarded a lot of jobs in terms of Cummins. We've significantly expanded 2 companies. IAPS, University of Bath, they're now able to take on more funding opportunities and more students because we've been able to successfully deliver this project. And say from a Cummins point of view, we've now got much stronger technology portfolio. So,
if fuel cell technology takes off and we see a lot of on-road, off-road applications using fuel cells, then what in terms of the benefits?
Well, in terms of the benefit, I mean, we've got technology ready to go. So in terms of the competition, making sure we're ready to go, we can provide samples to customers and so on. The technology is there. It's already validated to the right level to be able to say, yes, you can put things on a field trial, we can go into limited production. So it's really kind of enabled us to leapfrog some of the competition and have a product that's ready and there to go. And the great news is, that skill set and that knowledge is UK based. And even when I look at Cummins, we're now upskilling our workforce to look at the new technologies, the e-turbos and so on. So again, if we hadn't done this work through APC, that would have been further delayed. So we've got the technology side of things and the product side of things, but we've also got the resource and the skilling of the employees.
So as well as the e-turbo for hydrogen fuel cells, you've been improving your conventional turbos for internal combustion engines, and that's got quite a lot of potential to save carbon as well.
It has. I think when you look at a turbocharger level, we've been able to improve the efficiency probably about 5% or thereabouts. But when you multiply that by the number of the volumes we will sell over the next 10 years and the number of customers and applications we have, we've calculated that's roughly 200 million tonnes of CO2 reduction we'll see as a direct output of this project over the next 10 years. So
we've covered a good chunk of ground there. Is there anything we've not talked about Trident or Cummins moving to a low carbon future that you'd like to touch on?
I think just to kind of reiterate, it's kind of aligned with our company vision in terms of reaching CO2 neutrality as quickly as possible. We our internal goals, Planet 2050 we call it. I know our collaboration partners have similar goals to attain. I think this has really helped us to accelerate towards that. 2050 feels a long way out. It's getting here quickly, more quickly than we think. But by getting these technologies in place, it's made that road to net zero much quicker. And it has really been, a real pleasure working with the collaboration partners. It has been a collaborative effort. It's great to see the benefits to all of the companies involved. And we intend to keep working with those companies moving forwards. We've got plans. We're talking about future opportunities, future APC bids. So I think this has been a real stepping stone for us and a launch pad to new things.
Thank you very much.
No problem. You're welcome.
Thank you for taking the time to listen to this episode of The Road to Net Zero. If you're an SME, an academic organisation, a Tier 1 supplier or an OEM and would like to get involved in an Advanced Propulsion Centre collaborative research and development project, visit apcuk.co.uk to find out more.
Thank you very much, David, and thank you for listening to The Road to Net Zero. Be sure to check back soon for more episodes and in-depth interviews from our project partners.